Hello, welcome to another Verasys video. My name is Rob Snowart, and today I'm going to cover our Lunch and Learn PowerPoint. So this is a PowerPoint that I've used a few times, gone through several revs. I'm up to Rev 7 now. For anybody who's really wanting to learn about Verasys, and I've got an hour to give. So anyway, I'm going to go over my Lunch and Learn PowerPoint. Hopefully, I'll hit it right on an hour, and we'll be good. So let me start. So I'm going to cover basically a Verasys overview and then go through what kind of systems that Verasys supports. After that, we'll cover some other systems and what other capabilities besides just HVAC we can do. And then finally, start to go through some of the support components, some of what is available out there for you to for Verasys and where you can get more information, where you can get help, etc. So let me start with the Verasys overview. So Verasys was originally created when we was is a kind of a concept or an idea that we had based off our smart equipment units. So we started with our smart equipment units, and we can connect up a cell phone and a map and connect to it. So we started to embed more and more smarts into controls, and the industry is really starting to go this way. So we've taken it another step and said, hey, really, we embed more and more into the controller, then we can utilize it to make it so it's easier to set up, so that you don't have to need any field programming, you don't have any software tools. All of this to reduce labor, so that way, pretty much anybody can connect to it, and then can connect it up for others to use. So we've started with this concept and starting to apply it to the light commercial mid-market space, where there is a lot of repeat systems and a lot of things that you see over and over. So that's what Verasys is intending to do. That light commercial space looks like this. They're small buildings. They're office buildings, they're retail, call it dock in a box, but you see some medical office buildings that they're pretty simple. A rooftop unit here and there, maybe some VAV systems, some changeover bypass, may have to monitor a few things. So Verasys is intended for this market. And you don't see hospitals, you don't see big education, you see K through 12, you don't see universities. Um, Verasys is really intended for the smaller space. So with that in mind, we'll show you a little more about Verasys. So some of the key features in Verasys is it's plug and play. The ability to have remote access, the ability to have alarm notifications. Those are all key features to us. So that way it's easy to use, easy to access, and it talks to you. It'll send out the alarms for you. Not a lot of programming, just a little bit of setup. So how is it different than a normal BAS system? So a normal BAS system will have an architecture similar to this. You'll have browsers that connect to the interface. You'll have servers that gather all the data. You'll have what we call network engines or supervisory controllers that talk to field controllers. And all of this setup is done to the supervisory engine. All the definitions, everything you see there in red, adding schedules, adding alarms, adding trending, providing a user interface with a web browser, having site directors that connect all the sites together, making graphics. All of that is costly to set up. So with Verasys, it's plug and play. It'll set itself up just by connecting it. So let's talk a little bit about that. With Verasys, we have what we call a smart building hub, and our smart building hub will provide a Wi-Fi hotspot. As you can see, it looks pretty much kind of like your router at home in a sense. So you connect up to our smart building hub, and then through a BACnet MSTP trunk, you connect up to what we call our BACnet field controllers, which have embedded smart equipment technology in them. This is where we have alarms, trending, schedules, those view definitions. Everything that was in that supervisory controller above is in the controllers for Verasys. So when we connect up a controller in Verasys, the device connected up and address it, the device will automatically appear in the Verasys windows and connect up appropriately to whatever systems we have. So let's kind of recap what I mean by that. So I have these smart equipment controllers, whether it be a rooftop unit or an application controller or a TEC thermostat. They have what I would call already built into them an application layer. That does the function of the rooftop or controls whatever it would be. So that's normal. That's what typically you'll have on a controller. But what you don't typically have is this supervisory layer where you have view definitions, trends, alarms, um, and translations, units. You typically do not have that. So what that means is we utilize that with the Smart Building Hub. So when you connect up the Smart Building Hub and you say, hey, or the device connects up to the Smart Building Hub, it'll let it go and hey, I'm here. And when you click on that device, it then pulls up that supervisory layer and shows you what it looks like, all the trends, all the schedules, any translations, any of the units, the trends. So anyway, let me go ahead and kind of demonstrate that. Going to open up my browser, and I'm going to go to my system. Stop that. So I'm logging into my system at home. And I have some devices connected up. Okay, I have some devices that are connected up. I'm in this, what we call a spaces view. So I'm going to take one particular device. I'm going to take my furnace, and I'm going to move my furnace from address 5 to 6. So I just clicked on it, and you notice it comes up with a view definition. I'm going to show you just some trends of what the space looks like. So the controller itself has some trends in there. It has schedules built in to the controller. Okay, various things to where I can manipulate that thermostat. But what I'm going to do to manipulate it is I'm going to move it from address 5 and I'm going to move it to address 6. Okay, with a standard BAS controller, this would have been a big problem. Reason why it would have been a big problem, all of those things that you define, those view definitions and the schedules, the alarming, all of that is defined to that particular address of 6. So by me changing it and saying, no, you're not 5, you're 6, what that does is moves that device. And the device on a supervisory controller would go offline and stay offline. As you see here in Verasys, it moved. So all of that moved, that schedule moved, those trends moved. It's all because it was embedded in that controller. So that is what makes Verasys very plug and play. It's all embedded inside the controller. This will eventually turn offline. So I'll come back to probably our screens here and show you a little bit more of some other features in Verasys as we continue on. But I wanted to show you what plug and play kind of really means. So that's what differentiates Verasys from other systems. So what do we support? Now, Verasys is limited. We have these configurable controllers. They're not programmable. We have lots of applications for them and lots of flexibility on it, but we only cover certain systems, and we're covering those systems for that light commercial market, those smaller facilities. Um, so the larger facilities, those more complex systems, they're going to require programmable controllers, and they're going to require a Metasys or an FX system moving forward. So what is it that we cover from an air system side? We cover single zones, and how we cover single zones is with the TEC 3000 or the Simplicity Smart Equipment units. So Simplicity Smart Equipment units are branded units made by Johnson Controls that cover a number of brands. So if you're one of the distributors that covers one of the Simplicity Smart Equipment brands, all that you need to connect up is a BAS card in that unit, and you wire it to the trunk. The TEC 3000 already has, you'll need to use the BAS cards, and you wire it to the trunk. We can add up to 100 devices on this system bus trunk. So, um, so the types of the other types of things that we can control in terms of air handling units, we can also do VAV systems and changeover bypass systems. So we can do VAV systems. We'll need what's called a zone coordinator. And then the unit wires underneath the zone coordinator with up to 32 boxes underneath that particular system. We can also do a changeover bypass system, and again, it's the same zone coordinator. And what it'll do, it'll look at the unit or unit controller to decide whether it's in changeover bypass or VAV. Can do up to 32 zones, which can be a combination of zone dampers or VAV boxes. Now, the VAC 1000 is much like the TEC. It's intended for third-party equipment. So the TEC is intended for other devices. With the Simplicity Smart Equipment units, we can control those directly. The only thing you need is the backnet card on it. So Simplicity Smart Equipment, or you can use Simplicity Smart Equipment or the VAC controller. We indicate all here that this is all smart equipment, means that it's got that embedded technology I just showed you. So we can cover mainly those systems, like I indicated earlier, that are in this space, VAV, changeover bypass, single zones, that's all in the light commercial space. So I'm going to go over some more details about these systems and the breadth that I can cover. So Verasys right now supports packaged units only. And what I mean by a packaged unit is a rooftop unit where you have a cooling coil and a heating coil are combined, or a split system where you have the condensing unit and the unit split out. So we look at either one of those as kind of what we're looking for as packaged equipment. What I'm also looking for is if it's a third-party unit, I'm looking for a conventional thermostat. Again, if it's a Simplicity Smart Equipment unit, then I don't need the conventional thermostat interface. This interface, you'll recognize it by, it's got the various terminals for how you connect up a thermostat, an R, a G, a Y1, Y2, a W1, W2. If it's a heat pump, it'll have a reversing valve. So this is a sign that you have a packaged equipment unit when you have something like this. And that's essentially what we support at this point in time. So single zone units, what does that mean? Single zone units are a single unit. You're controlling it with either a constant or either a TEC, or coming soon, we're going to have an application controller that can give you some more coverage. Need to move this out of the way. It's the second time it's bothered me. So we're looking for that. We're looking for it's a single zone unit, and we're controlling to a single space temp. So what can we cover with single zone units, or what's the advantages, disadvantages of single zone units? Advantages, it's pretty simple to control. just need a thermostat or some simple controller. It's controlling the space temp. The only problem that you really have with this is if you had partition spaces. So if let's say you had a wall right here, then this space can get a little bit warmer than this space because the thermostat probably be out here or it would be here, and so you start to not be able to get good airflow in all the spaces. It's pretty low cost, pretty easy to set up. So what is our coverage? So I indicated that we have smart equipment units, and smart equipment units just come naturally with the controls, and we can cover all of these different features with a smart equipment unit. So with a thermostat or a TEC, you can see I'm limited. I'm limited to 2 heat, 2 cool. I can do a heat pump and I can do an economizer, and that's about it. I have trouble with specialty things like Title 24 ventilation, demand ventilation controlled, dehumidification, humidification. That requires some more IO, some more complexity. But I indicated that this spring I'll be coming out with some application controllers. And those application controllers will look somewhat like this up here in the corner. And we'll be able to mount those into a unit and gather some more coverage. So I'm going to have a couple application controllers coming out with an app in May that will get us some more coverage and fill out somewhat of the line card so you can get more of what we can do with the Simplicity Smart equipment with other controllers. So here's a table kind of showing you what it is we can do and can't do. Now these application controllers, we'll be posting the application on our website, and it'll be something that you buy a controller that doesn't have an application and you apply it. At some point in time, we will have a specific controller part number that you can just order straight up and it'll have the code already in it. But to get speed to market, we're developing it this way at first. We also support VAV systems. So VAV systems is a unit that will have partition spaces. So best part about VAV systems is the VAV boxes. So you'll have a unit, and what the unit will do is it'll control and mainly just provide cold air down the duct year round. Then you'll have boxes that'll either reheat it or it'll allow the cold air to go through, or it'll allow it just to be neutral, depending upon your space conditions. So what a VAV system is called, or it's a variable air volume system, meaning that these VAV boxes out in the space vary the air based upon demand. It'll vary the air CFM. So we can cover many VAV boxes. So here's some styles that we can cover. Cover just a cooling only VAV box, which means that there's a damper and a flow pickup, and we vary that air volume into the space. With that, we have some options for supplemental heat if we need supplemental heat. Supplemental heat means heat outside the duct, and we can control some supplemental heat. So there's other VAV boxes, and they mainly will have box heat. So we have a style of controller that will cover VAV boxes that have staged box heat. Notice that there's also supplemental heat options too with these boxes that have staged box heat. We also have some that have incremental, would be incremental water, and likewise it would have incremental water for supplemental heat if needed. And then finally we have a proportional. So we have the ability to have supplemental heat that's proportional outputs. So just some options for the VAV controllers for reheat. Now there's 3 different styles. So you notice a -1, a -2, and a -3. We also have combinations of this with fans. So it's the same -1, -2, -3, but with combinations of fans, whether it be a parallel fan or a series fan. So with those 3 controllers, we can cover a lot of options on what you have out there on VAV boxes. Notice we don't cover any dual duct. We're expecting it all to be single duct VAVs. So again, we have 3 VAV controllers, 3 different models. Here's a screen for what is covered. We also cover third-party VAVs with our VEC 100 controller. It has some limits to it. I'll show you what the limits are here of that controller right here. So you can see that we can cover some of the things that a Simplicity Smart Equipment can cover. At some point in time, yes, we will try to cover more of this, but right now this is what we have. We also support changeover bypass systems. So a changeover bypass system is essentially a constant volume unit that will switch between heat and cool. It'll have a bypass damper to control for pressure, and then we'll have these zone damper assemblies that mount in the zone. So we can get controllers that can either be loose and mount on existing dampers, or we can have damper assemblies that you just mount into the zones. It is a voting system. So what that means is you'll count how many heat calls, cool calls, and we'll switch the unit from heating to cooling based upon that voting. We also have the ability to take and put VAV boxes into the space too. So that way you'd have some combinations of heat if you needed it. So changeover bypass system generally looks like this. It's a voting system. Very common um, in the light commercial market. With the changeover bypass, we have options with Simplicity Smart Equipment, and we could use Simplicity Smart Equipment, or we could also use our third party controller. And our third party controller again will have these types of limitations to it on what we can cover. So besides air systems, the single zone, the VAV, and the changeover bypass systems, what other systems do we support? So I'm going to cover those now. We support the TEC thermostats, the full line of the TEC thermostats, the communicating thermostats. So we have models of the TEC thermostat that are wired, and we have models that are wireless. We can cover both wired and wireless TEC thermostats. So we have a wireless system as well as a wired system for these thermostats. They can connect package units and unit heaters. We can also do fan coil units and VVT dampers, or I like to kind of call it zone alone. So I'll talk about zone alone here in a second, but we have options for the fan coil units and be on-off floating or modulating fan coil units. Again, these TEC thermostats come in both wired and wireless solutions. And what I mean by this zone alone, I mean they're pressure dependent dampers. So um, it looks somewhat like this. So remember the situation I indicated about a partition being on the single zone right at the beginning. And there would be a thermostat out in this space, and this could overheat or overcool. Well, we can compensate by that with a zone alone type of a controller, putting a damper up into the um, space, a damper with an actuator, and then we take a supply air temperature sensor and put it in the supply air temp duct. So what that does is we will see is hot air coming out of the duct or cold air coming out of the duct, and if it's getting too warm in here and there's still hot air coming out of the duct, we'll start to close this damper or potentially close it completely to not overheat. And likewise, or conversely, if there was cold air coming out of the duct to not overcool. So that what that does more or less is slave this zone, not really control the unit, but it keeps from getting too hot or too cold from because of the thermostat being in another location. So hopefully that makes some sense. Again, we would use these styles of fan coil units, and they'd be on, off, or floating, or modulating. I tend to always use the modulating and a modulating actuator there. That's typically what I'll use. The other system supported, now this gets kind of interesting. So We have a device called an IOM, or um, a VAC controller. So we have a style of a VAC that's an input output module. And with that input output module, we can take a and control things like a boiler. So we have outputs. We got 9 outputs on the top. We got 5 analog inputs and 4 binary inputs on this controller. And through an interlock, we can say we can bring in an outside air temperature here. And through an interlock command, we can go, okay, if this is above set point X or below set point X, turn on the output for the boiler. So we can do something like that. And if we wanted to, we could even monitor the temperature of the boiler. So if it got too hot or too cold, we could give you an alarm off of this IOM, or input output module. Same thing with chillers. So if we have just a single chiller, the outside air temp got above X, and we were scheduled to be on, we could turn on this chiller. So we have the inputs here to bring in the chill water supply in the return if we needed to. We could bring in an outside air temp, and we could turn on a chiller for the space. So, and monitor it. If it got too hot or too cold, give you an alarm. And those alarms can go to your phone. Okay, so what else can we do with this input output controller? I indicated that we could do all kinds of alarming. Um, this input output replaces the old input output, and it works with Smart Building Hub, the new Smart Building Hub that you've seen. So we can monitor pretty much any kind of input, pretty much any kind of binary analog, or with net sensors. We can set alarms to them, whatever levels we want. The input types can be resistive temperature devices, known as RTDs, or they could be 0 to 10 volt signals or 4 to 20 milliamp signals. We can monitor that, and you can set the low range, the high range on it. So I'll demo some of this here after I describe all of this. Same thing with the binary outputs. Well, the binary outputs, we could schedule them or we could interlock them. And then we have also energy meters. We can put up to 4 energy meters against this IOM, or against this VAC controller. So an energy meter will connect to the system bus or SA bus port, and um, you wire it into whether it be your bus bars or whether it be to your breakers, and it's easy to set up. The device itself will have a barcode down here, and the last 3 digits of the barcode, you just enter it in as the address of the energy meter, and you wire it in here and power it up. Got instructions on that, and it'll come in right away. And over time, it'll trend what your usage is. We could take this usage or your demand, and if we needed to do some sort of load shedding, we could. So it'd just be a matter of wiring in to shut down loads based off of energy demand if we need to. So we can do some energy monitoring, some simple load shedding with this particular device. The next thing we can do is we can plug in a one-to-one receiver for wireless signals, or we could wire in some net sensors. So we could bring in remote temperature sensors via net sensors if we want, or we could use a wireless receiver. And if you're within 50 feet of your devices, it'll talk to that wireless receiver, maybe a little bit further if you've got good line of sight. But one of the best use cases for it, for this light commercial space, are walk-in coolers. So I'm showing what we call a frosty sensor, and we set this on the outside of the cooler and then run that little thin wire through and mount it, onto the wall, and we can monitor what the temperature is of that. And we can even alarm. So if we were to rise above, 42 degrees, and it's been that way for a half hour, we can delay it, then we can give you an alarm. So anyway, a lot of flexibility with this particular controller. So I'll continue on. We can monitor binary inputs. You name the contact, we got it. door contacts, being able to delay the door if it's left open 20 minutes, give you an alarm, water leaks, sump pumps, water levels, anything with a dry contact. You need to monitor a motor or a pump. If it goes off, give me an alarm. Really easy to do. As you can see, pretty easy to set up. You're going to be able to define your states text, normal alarm, open, closed, on, off. Those are the choices that you have. And we even invert it. So if it's alarm normal or off, on, we got all of that ready for you. You can name what it is. So as you name it, it'll change throughout the user interface. You can put what you want for an alarm text, dial 911, something pretty simple like that. Same thing with analog inputs. I indicated that we cover resistive temperature devices, voltage, current, um, you name it. It's as long as it's linear from a voltage and current standpoint, we're good. We got multiple temperature signals on those RTDs. We can do platinum, nickel, negative temperature coefficient, type 2, type 3s, the ability to do that. We can monitor CO2 sensors, CO sensors, building pressure sensors, light levels, all from this one input and output. Notice we can change the decimal precision. Notice we can change the units so we can match what you need. So I'm going to demo this pretty heavily here in a bit, but it's a very powerful controller for monitoring things. And then finally, we can also input or do interlock. So I show an interlock screen here on that load shed. So if my current on that meter got above X, do this. And, you can see you can do a couple of conditions for it. So if then type statements. So over here on the right, these are kind of all the things that we could control with these outputs. So we could do exhaust fans, we could do lights, we could do boilers, chillers. We could even do the hot dog roller at your local convenience store if needed. I've had a customer actually ask me if I could do that. Thought it was kind of funny, so I'm put it in my PowerPoint. Yes, we can do hot dog rollers. All it is a load. We're just switching a circuit. Okay, so I've got just a couple more controllers. Lighting controller is another one of our application controllers that we have. We can take and control up to. I'm going to just switch to this, and then I'll go back to a demo. We can take and control up to 9 lighting contactors. Those lighting contactors can be normally open or normally closed. We have the ability to take those contactors and assign it to zones. Each zone is adjustable. It could be done off a light level sensor, or it could be switched off of a light level sensor or a schedule or a combination of both. So you have lots of options on what it is we could do to bring these lights on and off on a daily basis. The other items that you have the ability to do is you have the ability to bring in some inputs to the spaces where we don't. We can monitor or have up to 7 override inputs. So what a use case is for this is, let's say that we have some cleaning lights in a facility, and you needed to bring on the lights after hours. So you could then take and put a push button against one of these, and you can define it as a momentary signal. You press that button, the lights will come on for a period of time and then shut off. So you could define it for what, hour, half hour, or 2 hours, whatever you want. Just gives an extra amount of time that they'd be open. If it's maintained, it could be just a straight light switch. You turn it on, turn it off, it's off. Or it could be like an occupancy switch that you could connect up to. So you walk into the room, it turns on, and then turns off after a period of time. And then you got the ability with your schedules to schedule it on so it's on. You don't have to worry about the occupancy switch made. But those are the kind of things that can be done with this controller. Plug and play, easy. So that's what we designed that for. And then finally, we're coming out with pin refrigeration control. So that walk-in cooler that we were monitoring, we could control it. And that's with the pin A525 coming out this spring. So in it, we'll connect up to Verasys. So it'll be plug and play. You just set the address, it shows up, and you can go ahead and see the definition or see the points, see the walk-in coolers, get alarms, send those alarms to your phone, all of that into the one controller. So we have the ability not only to monitor walk-in coolers, we have the ability to control it. So as you can see, there's a lot of stuff within Verasys that just a typical, just don't get it from a thermostat in most building automation manufacturers. So I'm going to go ahead. I'm going to demo before I get into the components. I'm going to demo a little more of this IOM controller and that lighting controller. So I'm over here on my IOM. So this is my input output controller. And so I'm monitoring, or I have the shutdown feature. So this is a feature that we have built into Verasys to where you can define with an IOM what point would be for load shedding and what point is for global shutdown. So we have those features. Global shutdown meaning a input will shut down all the units on the site, all the smart equipment units. Um, I have a water detector, a sump pump alarm, and then I've created just a bunch of other kind of interesting things. So outdoor light level, this is a real light level. I'm controlling some outdoor lights with it, scheduling some exhaust fans, hot water circulation pump, some made up things that I've done. I have one of those frosty sensors hooked up to one of my refrigerators, and I have a basement temperature sensor, which is these two are wireless. So let me show you how all this sets up. So I come into commissioning. I also have an energy meter. So energy meter, like I indicated, I just input those last 3 digits and it shows up and it's monitoring the energy usage that I have currently going on in my house, well, in my basement. So with it, here's what the energy meter looks like. I'm monitoring each phase. I can set alarms on it. So if it goes above a particular voltage, it'll give me an alarm. As you can see, pretty close to that alarm level. It was 124 volts. The other day it did go off and send me an alarm. I thought that was kind of neat. S phase. So this is just monitoring some power here. So Alexa, turn off the basement. So I got my Alexa here turning off the basement, and that'll should drop this amperage here. While I'm talking or while we're watching that, is I've got a high text alarm, so I can say what phase it would be. That would be high alarm, low alarm. You can see that just dropped. That's all just because I turned off basically turned off my stereo. So the other things that we can do with this meter is I can make it into a water meter. We got pulse inputs. Should probably say that first. We got some pulse inputs that we can say they're present up here. And when we say they're present, that means on the backside of that same meter, that's electrical meter, we can bring in a pulse. We can put a scale factor there. We can change the units. It's pretty impressive how many units that we have available for you to change to. So got about every unit covered. Change the units, and then we can go ahead and we can monitor your water. We can monitor your gas. Again, cubic feet, name it whatever you want. So the scale factor there means every pulse is worth this amount of value. So generally with pulse meters, that's how they work. Inputs. So you saw the shutdown and the load shed. Those are already kind of predefined, and they just take over that input. If I didn't have them there, I could use them. So if I just took it out, I could use them as whatever I wanted for. You can see I added water detector alarm. We got the ability to delay that alarm actually. If I wanted to delay it on, it's got to be wet for X amount of time. I don't know. Then send an alarm. But this would be where you could do like a door contact, and I could delay it there before it kicks in, or I could delay it here on the actual output itself. So it could be in alarm, or it could be open, and just not report it until XYZ. So it just depends on whether you don't want to show it or you don't want the alarm to go in. So you delay it one way or another. But it's kind of cool. Well, I hope this works. Please work. Yeah, did. Reason why I said please work is we've been working on a bug that we knew we had, and I hadn't tested it yet. But when we changed this name, it wouldn't change it. I'd have to turn off the enterprise. We'll talk about enterprise in a bit. So anyway, same thing here. I want a sump pump alarm, whatever I want to name it. Same kind of delay. So I put a delay there. So I don't know why I'd have an off delay, but I just put an off delay, delayed here. This is where I can bring in various inputs. So define a water flow rate as a temp. So let's correct that. So we'll call it a voltage. So it's going to be a voltage. We got GPM. So those units changed, and notice it didn't change right here. And that's just because we do work in a browser situation. So I've got a Chrome browser is what I'm using. I'm going to go ahead and I'm going to refresh my Chrome browser because those units do get cached in the browser. And the caching. Okay, that's what I was afraid of. Let me go ahead and do this. Okay. All right. There's the GPM. So that kind of showed you what I was talking about. I needed to turn Verasys Enterprise off in order for the the values for the system um, to update. So one of the things that happens with Verasys Enterprise, and I'll talk Verasys Enterprise here in a bit, but is it takes then and pretty much connects you up to the enterprise, and this particular level of control kind of gets a little messed up from that. So anyway, that's just something we're working on to correct that. I thought maybe this new build would have it. Had some of it. So let me go back to my inputs. So you see I was doing that water flow rate, GPM, so I can say, oh, it's voltage. So I want a 0 to 10 is equal to how much GPM. So 0 to 250, and then I put an offset. You can put an offset. I put an offset just so it's out of range. So let me put an offset that's better, or a range that's better. So if I zeroed this out, I'd just go unreliable because I don't have anything hooked up to it. Generally, it starts off at 0. So you can see I can add alarms to it, how high, how low, etc. So anyway, um, that's the inputs. So we have 5 of those to define various things. You can see here I got an out light level. I'm going to go ahead and show you my light level. Turn on my lights from my outside, which is an interlock. And here's how that interlock is defined. So if the light level is greater than 26, differential of 1, turn on my outdoor air light or outdoor lights. That's what an interlock looks like. We could also schedule those outputs. So our outputs on the IOM, I'm going to go ahead and quickly name one. We'll call it test. Okay, so I named it test. So I'm going to just quickly schedule that. I come to the schedule feature for Verasys, and I add a new schedule. We'll call it test. So you can see I use test a lot. So I can go through here and I can add, whatever the schedule would be. I could add some exception schedules. Exception schedules meaning calendar dates that are different than the daily schedule. So the day or the 16th will be different than what it is today. Um, and then I select what objects I want. So, oh, hey, it looks like I actually used that test in another one, another schedule. So I'll just say one lower than that. I'll do binary input 6. So this tells you if it's already being used, and I'll save it and then save it. And that's how we would um, schedule IOMs. It's how we would schedule other things. So you're seeing a lot of the interface for Verasys that we have the ability to do. There's a lot of videos out here that go over these controllers that are out on verasyscontrols.com. I'll go over verasyscontrols.com, but anyway, this gives you kind of an idea of some of the things that we can do with that IOM. And I really wanted to cover that because it's really, really powerful. I went ahead and removed that offline that we created. And so I'm going to finish up the slide deck. I'm going to go over the components and see, just kind of go through what Verasys all is made up of. So we have Simplicity Smart Equipment Units. So that's one of the key components. We just do single zone units. We have a set of thermostats, the TEC models that can do these units, third party, or they can do some fan coils, or they can do the zone alone. We have a multi-zone unit for third party. So our Simplicity Smart Equipment units can do multi-zones automatically. It's already built into the code. But this can do it for third party units. You do changeover, bypass, or VAV. And then we have one model of coordinator, looks at the unit, switches that way. The rest is the zone controller. So we have a zone controller for VAV, changeover, bypass. We have a VAV box controllers. We have 3 of those, 3 models. We also have a bypass controller. And then we have, oops, accidentally hit my little wheel. We have 3 different types of application controllers, and we're starting to develop off of those. So we've created that lighting controller, that IOM, the interlocks, the IOM controller. And then we're building some library of solutions, and ultimately those will come out as controllers that we would sell in addition to everything. Then we have our refrigeration controller, our pen refrigeration controller. And then finally, our smart building hub. So our smart building hub, this is a new look to our smart building hub. It's a new smart building hub. We enhanced it. We've got more storage and updated operating system. Allows us to do more with it. So one of the things it's allowing us to do is enterprise cloud services. Talk to that in a bit. But we also use a Wi-Fi dongle port. So we've had customers with our old legacy smart building hub tell us they'd like to be able to turn off that Wi-Fi. Well, we can turn it off now with um, this dongle. So kind of a nice feature. Plug it in, set it up, unplug it, and then you can use the Ethernet port here, connect up to the system. So you saw my demo here. That's just using the Ethernet in my house. And then we also have a 24-volt terminal and then a permanent terminal for your system bus. We have more diagnostics LEDs. We also have an inline switch built in. All features we didn't have on the other hub. So what else do we have? For Verasys, we have an enterprise dashboard. So just released this spring was our 3.1 release. With that smart building hub, we can connect multiple smart building hubs together in an enterprise form. So imagine you're in a city and you got multiple sites that you want to monitor. We can monitor those with this dashboard. So we can connect multiple sites to one dashboard. Great service opportunity, great value add. There's monthly and yearly subscriptions, and I'd say to contact our local salesperson on more information about this, as um, getting connected up and wanting to subscribe to this is takes a little bit of a process to get customers signed up. Um, Other things on that dashboard, not only you're monitoring your HVAC, your lighting, but you'll be able to monitor those IOM inputs. So you're monitoring those refrigerators. You will get trends on those points and be able to download trend history, etc. On that energy meter is going to come in. So you can see the load profile of what your energy meter is using. So it'll tell you what the maximum peak was that day, the minimum and the average. All of those things come with our dashboard. So a lot of neat little diagnostics that we have that are above and beyond the Smart Building Hub. Basically, what you can do for data. Notice or note that the trends that we have on devices inside the controller. So they are about 200 points to be able to trend, or kept 200 samples, and then it overwrites each other. There's no long-term storage in the Smart Building Hub. Our long-term storage is done through the dashboard. So that's how you can get trends that are longer than what we currently have. And then finally, just some things that are coming out. We have these Verasys application controllers just released. So we're making some new controllers with it. And I talked a little bit about the constant volume controller. And what we want to do is we want to be able to have a set of controllers where we take, an 18-point controller and we could expand it and we could get everything. So this is not going to be able to come out right away. We have some work to do in the factory to make all this happen. We have stuff to kind of set up for all that. But we have the application ready, and we've tested the application on a few sites. So we can deliver that by using a application controller that does not have an app loaded in it, and we can set the application out there on the website so people could download it and they could get some coverage. But you'll get the coverage without the expansion. So if I used a VAC 1000, which has no application in it, and I loaded my application in it for it, this would be what I could do with it. And then conversely, I can use the 32 point and basically get everything but humidification out of it. So great, great uh, feature that we have with these application controllers, even the blank ones. We can utilize them and get people solutions even quicker. So that's really, really nice. That's coming, in May. I'll have those types of things ready, along with some documentation on how this app works. And so we'll, of course, have our support piece, which I will talk to you about around here in a bit. So, what are the advantages of Verasys? So, when you're using our smart equipment controllers, we have the ability to add even more on top of our Simplicity smart equipment, I should say. Simplicity smart equipment units. We have the ability to do fault detection on it. So we have a complete full FDD offering of equipment, monitoring, and controls. So not only we control it, but you could add the fault detection diagnostics that allow you to get even more info on your units. The ability to know low charge, high charge. Are you plugged on some of those coils? Are you really working properly? We also have the ability to be Title 24 economizer compliant. In other words, is our damper stuck? Is it not economizing like it should? We have excessive outside air. Those type of things we generate alarms with our detection diagnostics. The economizer piece is standard. The other is an add-on to the Simplicity Smart Equipment units, but can be added on. So we have both of those options. Now, what does fault detection diagnostics do for us? So this is a diagnostics that we have developed and worked with FDSI systems on, and uh, it has the ability to be utilized for some nice things, not only for the customer to know more about his unit and if things are going on, but also from uh, the standpoint that if you keep your unit running efficiently, then and keep maintenance up on it, and your refrigeration cycle is going smooth, you have the addition to add on some life to your unit, and then also not have to absorb some costly repairs. So the cost of the equipment will go down over time because you'll keep your equipment running smoother for longer. So, what kind of things does it do for a mechanical contractor? Well, when you're a mechanical contractor and you can call up and you can essentially, through Verasys, look at these pressures and these discharges and get your, um, uh, get your subcool and subheat uh, values out of your unit just through looking up Verasys. It means that a service call could be, hey, I grab everything I need from the office and I go there. Or maybe I stop at a certain spot because I know exactly what I need, versus going to the site, then going and finding some things and then going back. So it it allows you to be more efficient. It also allows you, if you're monitoring it via an enterprise type of site, to let your customers know of issues before they even know they have an issue. All really, really good stuff. So these alarms from fault detection diagnostic alarms will show up in our alarm screens on our units, and it'll tell you what's wrong. But we also have tables of what we recommend that you can do, or what could be the problem, to help you figure out what is wrong with your unit. So our Verasys advantages are we deliver building automation systems without the complexities. We can cover more than just HVAC. We can do even hot dog rollers. So we can cover a lot of stuff. We have a growing suite with those Verasys application controllers that we can cover in more solutions with that suite. What will this do for the customer? Well, it's going to reduce the cost per square foot for us to install. So it's a cheaper system. You're going to get more bang for your buck, and it's going to allow you to know what's wrong with your building right away. I take, for instance, that walk in cooler monitoring. Okay. If we could catch a walk in cooler uh, alarm, and you can catch that without the product inside getting spoiled, and you can get it fixed without the product getting spoiled, we just paid for your system, or you just paid for the Verasys system. There's a lot of inventory that's in those freezers, in those coolers, that need to be protected. This is one way to do it. We also deliver a system, it lets you know when there's a problem. We can email and text you alarms um, through this system, and do it simply and easily. So, what else do we have out here for customers? We have that website. I've already referred to verasyscontrols.com, and I'll cover what's underneath that. But we also have an operations support team. So um, just calling a 1-866 number will get you pre-sales and post-sales support, and we can get you under your way on whatever questions you have to get your building all set up. So as a mechanical contractor or building owner, mechanical contractor, we have kind of a 1-800 hotline on how to get started, where to get going, and those kind of things. So some help to help you get things done right. Then we also have that website that I indicated to you. We have a partners login, so you can log in um, and get extra things through our partners login, more information, more videos. We got how-to videos on how to set these types of things up, more info out there to allow you to design and install and troubleshoot your Verasys system. Again, 866 number. All kinds of documentation out on our Quicklit as well as verasyscontrols.com. Links are going to be linked together on the smart building hubs, the IOMs, the thermostats. A lot of literature involved in that. We have drawing templates available for you. So if you're Visio savvy, we can get you some drawings for how that works. So you know the sequences. the 866 number. Um, uh, if you talk to them and you've sold a Verasys job, we can do uh, drawing packages for you so you know how to install your system. Again, we have some how-to videos out there. They're under resources, and if you go and you select up here, um, you can go through. Right now it's showing 29 videos, but there's going to be closer to 40 videos here in a little bit. So that is it. So hopefully you got a lot out of this Lunch and Learn PowerPoint. Hopefully it covered a lot of things that you want to see in Verasys, and hopefully it's the solution that you use for your light commercial systems going forward. Again, thank you very much for watching this video. I hope you watch some more of our other Verasys videos in the near future. Thank you.